Hi guys, in this video we are going to take a look at how to find the equation of a tangent plane to the following surface at the point -1, 4. So I actually am trying to actually show you what this looks like. So this is the surface, right? I typed it here. And then I also added the point. So I plugged in the point -1, 4, and I got 1 for the z coordinates. So I need to plot the point -1, 4, 1. So if you can see this red point right there on the surface, that's where we're trying to find the equation of a tangent plane. And so we can actually do that using the software. The way you do that is you have to click over here, see where it says right here, where you can like select a point. So if you select a point and I want -1 and 4, okay, so now it fixes that point. It actually tells me the z coordinate is 1. But if you want to add a tangent plane, you got to go back over here to that little arrow. And that's where you can actually show the tangent plane at a point. So also the equation of the tangent plane, by the way, is going to appear over here on the top. So you can see this little plane, right? I don't know if you can see the little green plane, but it has to basically represent the surface. It's like touches the surface. It's just like a tangent line, but this time it's tangent plane. So I don't know, this graph is kind of hard to see, but anyway, let's go ahead and go through the procedure of how to find the equation of a tangent plane. And then we can actually compare with what they got and see if we get the same thing. Okay, so first I just wrote out the f of xy, and we want a partial derivative with respect to x first. So let's look at the terms that have x. So this term has x, this term has x, and also this term has x. So when you take the derivative with respect to x, you're thinking of y as a number. So all the terms that do not have x will just drop out, okay? Now, x cubed derivative is 3x squared. 9x is -9, so that's just regular derivative, right? But what about that mixed term x squared y? So think about y as being a number. So how would you take the derivative of something like 5x squared? What would you do with 5? You would keep it, right? Because it's a constant multiple and multiply it by 2x. So same thing here. You have y x squared. So you keep the y and multiply it by 2x. So this would be -2xy. Okay. So that would be the partial with respect to x. Now, with respect to y, we want to actually get rid of the those terms so we don't get like confused what's what. So let me also change the color, maybe blue. So I just want the terms that have y, and I do not care about the other ones. So this term has y, this term has y, and this term has y. The other terms will just drop out. So here I'm gonna have fy. So the -x squared y. Now think of x squared as being a number, even though you think, oh, that's 2x. No, 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 no. X is now a number, so x squared is a number, so we keep it. So how would you take the derivative of -5y? Well, that would be -5. So -x squared y would be -x squared. Okay, then it's going to be plus 2y and then plus 8. Okay, so that would go in here. Let's see. -x squared plus 2y plus 8. All right. Okay, so the next thing is to substitute the point -1, 4, and not just in the partial derivatives, but also into the original function. So I will do that using Desmos calculator. So I already actually entered the original function over here, and I know that the value at -1, 4, which you could do without a calculator, but the calculator really helps, and just gonna give you 1. Okay, next we want the partials. So we're gonna fx. Now to type fx, you have to do a subscript, and a subscript is shift minus. Okay, and then you type the little x, xy. I mean, you can call it g of x, right? But I just like to call it whatever it is, so that I don't get confused what's what. And then fy also, I'm gonna type that in here. And now I want to plug in the point, -1, 4, in both partial derivatives. And so I got 2 and I got 15. All right, so once I get that, then I'm going to use the formula for the tangent plane, which is going to be on the formula sheet. So here is how that looks like. So tangent plane, we'll call it T of x and y, is going to look like this. First, it's going to be the original function where you plug in whatever point you're trying to find the tangent plane at, okay, then plus partial with respect to x at that point. That's why we were evaluating them, times x minus x0, okay, plus fy also at x0, y0, whatever the point is, multiplied by y minus y0. Okay, so that's your tangent plane. And that's also equal to z. So you can say that this is z equals, okay? So this is like z equals that, all right? Because they have z here. Okay, so let's just substitute everything we know. Well, our x0, y0 is negative 1, 4. So we're going to say, okay, that's 1 plus fx, which is 2, times x minus x0, but x0 is negative 1, so we're subtracting negative 1, okay? Then it's going to be plus fy, and then we do y minus y0, which is 4. Okay, so that's equation of our plane, but we want to rewrite it because we want to make sure we simplify our answer. So this will be 2x, these two minuses will give us a plus, so plus 2, because remember we distribute. And then we're going to get plus 15y minus 60. So simplifying that, that's going to give me 2x plus 15y. And let's combine the numbers. So 1 plus 2, 3 minus 60 would be negative 57. So I think that's going to be my answer. Now, one thing that you should check before you move on, if you think this is correct, okay, so if you think that the tangent plane equation is correct, so let me type what it is. Then at the point where you were trying to find the tangent plane, it should have the same value as the original function, okay? And it is, which is just kind of like a double check for me to make sure that that's correct.